All right, let's dive into one of the most fascinating corners of AI, unsupervised learning. Now, at its heart, it's pretty simple. It's machine learning that works without any pre-labeled data. So that brings up a really big question, right? How on earth can a machine learn anything useful if we don't give it the answers to study from? It's a great question, and it really gets to the core of why this whole approach is so powerful. When we say unsupervised, what we literally mean is the model is given a pile of data without an answer key. There's no correct answer for it to aim for. It's not being told, hey, this is a picture of a cat, or this is an apple. It just gets this mountain of information and is basically told, okay, figure it out. And because there's no answer key, the entire goal just shifts completely. We're not trying to predict a right answer anymore. Instead, the model is on a mission of pure discovery. So, to see where this fits in, let's just zoom out for a second. You have the huge field of artificial intelligence. Inside that, you've got machine learning. And unsupervised learning, well, it's a major branch of that, sitting right next to its more famous cousin, supervised learning. So the model's job is just fundamentally different. Its main task is to explore. It's looking for the natural structure inside the data itself. Think of it less like a student cramming for a test and more like an archaeologist in the field, digging for hidden artifacts nobody knew were there. And that contrast is everything. Most of the machine learning you probably hear about is focused on prediction, trying to guess a future stock price or something. But unsupervised models, they are all about discovery. They're built to find patterns you didn't even know you should be looking for in the first place. So how does it actually work? Well, the model just sifts through all the data and starts grouping similar things together. It finds these underlying patterns that no person ever defined for it. And this makes it incredibly good at one other thing: spotting anomalies, those weird outliers that just don't seem to fit with anything else. Okay, let's make this way more concrete. We're going to use a classic, real-world example that businesses use constantly: customer segmentation. So, picture a company that's collected years and years of raw customer purchase data. Just a massive list of who bought what and when they bought it. But there are no labels. Nothing says this is a loyal customer or this is a one-time shopper. Now, an unsupervised model takes all this raw data and just gets to work. Without any instructions, it starts to find similarities in how people shop, and suddenly these distinct clusters just emerge. It might automatically group customers into frequent buyers, seasonal shoppers, and new buyers. And here's the amazing part: no one told the machine those categories even existed. It discovered them all on its own. This power of pure discovery is pushing the whole field of AI forward in huge ways. So what's next? Where does all this lead? Well, it leads us to the next evolution: self-supervised learning. This is a really fascinating idea, where the model actually creates its own training signals directly from the data. It's almost like it's generating its own labels from the raw input. This is a giant leap towards teaching machines to learn more like we do. And that leaves us with a final thought to chew on. If a machine can find hidden groups in customer data without being told what to look for, just think, what other hidden patterns in science and medicine, in the world all around us, are just sitting there waiting to be discovered?